Okay, so we have discussed how to train the CNN model or the convolutional neural network on some dataset. So we have downloaded the dataset of brain tumor and we have sorted that dataset into two categories, training set and in the testing set. So in the training set we have stored around 80% images, and in the testing set we have stored around 20% images. And then we have developed convolutional neural network model and we have trained our model on it. And after training we have received our model as a train model.h5 file. So we have saved that model in our current folder. So you can see here is the model. And at the end we have also plotted the accuracy and the other parameter loss of our neural network, and that was plotted in the form of some graph. So, in this lecture, we are going to talk about how I can handle the train model and how to apply an input image to this train model. And once the image is given as an input to this model, what will be its result? Okay, so that's what we are going to discuss. So, here in this session, we will be using a train model, previously trained model, and what we will do, we will just give an image as an input to that model. And once the image is given as an input to that model, it will be predicting the result. So it will predict the accurate result for given input image. So that's what we're going to do. And for that purpose, I'm having this test image in my folder. So I have just randomly picked one image from our data set, and this image we will test. You may pick any other image also, or it can be any real-time image as well. So this image, the test image.jpg, which is now in this particular folder, that we will be using for testing the CNN model. Okay, so now that's what we are going to do in today's session. So we will be creating a new file to test our CNN model. Okay, so in order to create the new file, what I will be doing, I will be creating a simple Python script over here, and this time I will be giving name as cnn underscore test dot py. Okay, I think something went wrong. Okay, we'll reshare the screen. Okay, so what we will do, so I will create here a new file called cnn underscore test.py, and here I will be writing new code that will be used to test our CNN model. Now again, number of things we are going to do over here. We are going to add some libraries as usual. So the first step is loading the libraries, and that's what we are going to do. So loading the packages. And the number one package is the TensorFlow. So import TensorFlow dot keras. So from PIL, next one is we have installed this library PIL import image, and also image operation. So this is actually the library or the function that is going to be, or it's for the operations on the image. So this is these two things, these two important things we are going to do here. So first of all, the TensorFlow library, and second one is the PIL library. And of course we will be requiring the NumPy library. So import NumPy as np. As usual, we import this library as np. And now next important thing is loading the model. So here you need to load the model. So loading the model. So in the previous code, we have saved that model by train model.h5 name. So in this session, we will load that model. So we're not going to train it. So already the model is trained, and now we will make use of it. So we will give some name model equals to this TensorFlow dot keras dot models dot load model. So it will be load underscore model, right? So this is how we'll be loading the model from this library. So the TensorFlow dot keras dot models, and from that load underscore model, and then here I should give some name to the model. So now this time it is train model.h5. So that's the name of my model. So that will be loaded over here. So this is how the model will be loaded, and to this model we will be giving some image. Now we will load the image from our computer, and that image will be just given to this model, and after that this model will do some prediction, or it will generate some sort of result. So that we are going to try over here. So let's start this and let's understand what exactly this is going to do. Okay, so in order to give some image input, so we'll create an data folder or data variable. So in this particular variable, we are going to pass the image, or the image data will be stored in this particular variable. So initially we will create an empty variable and with some shape. So we'll give some size to it so that exactly that sized image can be given to our model. So as you know, we need to give 224 by 224 by 3. That's our image size. So we'll be considering that size only. So we'll create an empty array, and by the name data, and using numpy library. So numpy or the npy or np dot nd array. So this is the function that is used to create the array. Now first of all we need to give a shape, so as an input. So shape equals to, now first argument is how many images you want to pass. Now this is I will be passing only one image. What will be the width of my image? It will be 224. What will be height my image? It will be 224. And how many dimensions? It will be 3, because image is having 3 number of channels. Okay, that's fine. And then you need to specify the data type of it, and by default its data type is float. If you see in this help, so by default it's float, so it's totally fine. But what I can do, I can mention here np float, so that it will be taking from the numpy library. The type equals to np dot float 32. So it will be a 32-bit floating point number. That will be the data type for the image that we are going to upload over here. Okay, so that's it. Now the next step is loading the image. Now for that I will be creating a variable called image, and then I will be using the function or this library image dot open, and then you should give some name to your image. Now my name is testimage.jpg. As you know, here is the testimage.jpg. So I will be loading that image. So after once you load the model, the next step is loading the image. So here, loading the image. So we have done two important things. First of all, we have loaded our model. Second, we have created an empty data array where the image can be stored, and in this particular data variable I am going to store the array of my image. And next step is to load the image. Now first of all I should load this image, but this image cannot be directly applied to our model. Okay, so as you know that this particular image in the form of matrix, and it is three-dimensional matrix. So first of all, and secondly, this image can have any irregular shape, because this image I can take from anywhere, maybe downloaded from the Google, or maybe the actual patient CT scan which is coming from that CT scan machine. So this image will have different size. It cannot be 224 by 224 by default. It may have some different size. So first of all, I need to resize the image. That will be number one thing. Secondly, as you know, for the neural network, or for the train model, you should apply image in the form of array. So array is important, one dimensional array is important. So we'll be converting our image in the form of array, and once the array is generated, only in that case we can apply that image to our model, and then the model will predict the result. And secondly, additional steps like normalization of our image or the array, that we can additionally add, and after that we can give that to our model, and after that the model will predict our result. Now first of all, we are having this image. Now let's resize this image to some different size. Now what size we need? We need the size of image to be 224 comma 224, okay, because this is the size which we have used to train the model. Now we will make changes. Image equals to, we will try to resize our image. Dot fit, that's the function. So image operations dot fit. So which image you want to change? This image only. What will be the size? This is the size I have just defined. And while resizing, it should not degrade the quality of image, or it should not basically degrade the information content from that image. For that purpose, anti-aliasing filter we will apply. So this is basically image anti-alias. Basically what it will do, it will try to maintain the information content in the image even if you resize the image. So after resizing, sometime the information content in the image may get lost. So in order to avoid that, we will be using anti-aliasing filter over here. Now this will be fitting the image to the desired size. Now next important step is converting this image array, this image into some array. So let's say turn the image into array, because array will be required to give input as an to that neural network. So that will be image underscore array as a variable I will be creating over here, and then np dot as array function. Okay, so this as array function will convert your image to array, and this time instead of a, here will be a image. Now first of all, we have loaded the image, then we have resized the image, and then we converted that image to array. Now this image is ready to apply, or this will be can be directly applied to the this neural network or the train model, but we'll normalize that image. So the next step is normalizing the image. Now what is normalization process? So that we'll understand. So normalization is nothing but converting to a standard range. Now for example, the image initially having the pixels from 0 to 255, that's the maximum number, or 256 we can say is the maximum intensity present in that image. So it is not zero centric, that means 0 is not at the center. So it starts from the 0 and ends to 256 or 255. Now if we can make it to zero centric, that means some values will have minus 1 to, let's say, plus 1. That will be a normalized thing, which will be a zero centric. Or it may be 0 to 1, so that will be normalized to 1. So that means it is converted to some standard range. So that's what we are going to do, the normalization process. It will convert our image to some standard range, or it could be some zero centric thing. So in order to normalize, so I'll be creating variable, let's say normalized or normalized image array. So normalized image underscore array, let's say, and for that purpose simple mathematical operation will apply. So we'll make it from -1 to 1. So image array, that's what we have called as type. Now this as type function will consider its type as something. So np dot float 32, because this is the standard type which we are using. Okay, so this np dot float 32 we have also used over here data type, and same data type we want over here. Divide by, if I do divide by 127 and then -1, if I do, what I will get? So let's understand this thing. So how it will be converted to some zero centric thing, or what, how it will be the zero as the center value for this calculation. Okay, so first of all, if you see here, this is the image array, or otherwise I'll be putting the complete bracket over here so that you can understand it more clearly, and then minus 1. So if you do like this, so let's see what happens. Now first of all, this image array, so every element or every pixel from it will be taken in the terms of floating point number, and then this is divided by 127. So consider the pixel is 256 over here. So consider, for example, if it is 256, divide by 127 minus 1. So it will come around 256 divided by 127, or let's say 128 if you consider, it will be around 2 minus 1. So let's assume it is 1. For example, the pixel is black pixel, and in that case it's 0. So 0 divided by 127. So that will be 0. 0 minus 1. So it will be minus 1. So here the range is converted with the range of the intensities, which is from 0 to 255. It is now converted to minus 1 to plus 1. So that's in that way it is normalized. So in that case we can say the image array is normalized. Now this normalized image is ready to be operated. So we'll put this in the data variable. So data of 0, that means the first element only, equal to normalized image array. Okay, so now what steps we have followed? Now first of all, loading the model, then loading the image, resize that image, convert that image into array, normalize that image to some standard range, and then apply or just store that into a data variable. Now this array, this is the image array which will be stored in the data variable, and the data variable is having the shape 224 by 224 by 3, and its number of images is 1. So in this we'll be putting the image. Now once image is here, now we can predict the image, and for the prediction we can apply this data to model. So now next step is prediction. And for the prediction, simply we'll create a variable called prediction, or that's equal to, or you may create result as a variable. So model dot predict, and then you just give data as input, this data variable as input to it. And now let's print the prediction, and let's see what result we get over here. So right now I'm having the test.jpg as an testing image or the reference image for me, and that will be tested over here. That is converted to some standard size, and again it is normalized, converted to array, and I have loaded the model which I have trained yesterday, and now this model will receive this data, and now it will predict some prediction. So now we are expecting some result after the prediction. So what will be the prediction? So we are interested in this thing, what it will print. So we'll check it out, and we'll see what exactly it prints. So it is loading the data and the libraries. Now here it is, it has printed something. So see this thing, this is the prediction. Now it has printed the NP array, and the first value in it is 0.66, and second one is 0.33. Okay, so that means, which means 66% chances are there. This is the probability value, whatever it has printed, these are the probabilities value. So that means 66% chances are there that the given image contains the brain tumor. Okay, because our first thing is in data set is the brain tumor, and second one is normal. So this first value is the probability of brain tumor, and the second value is the probability of normal, that this CT scan is normal. So this shows that 66% chances are there that the given image contains the brain tumor, and 33% chances are there that this is not containing the brain tumor. Okay, that's all the meaning of this. But this is not in the readable form. This output is truly is not in the readable form. So what we'll do, we will try to find out the index, or I'll just mark IDX, or the index at which this is the prediction is maximum. So np dot arg max function will find out the index maximum index, or the index having the maximum value, and from which array we need this prediction array. So this arg max function will find out the index of the maximum value. So here the maximum value is 0.66, which is having index 0, and this 0.33 is at index 1. So this will find it out which value or the index of the max value. So clearly the max value is 0.66 and its index is 0. So after that you can, if you want, you can print this index also to check it out. IDX. Now let me clear this thing and let's run this. Again it will load the libraries, and now see here we are getting 0 as index because the 0th value is maximum. The 0.66 is the maximum, so we are getting 0th index. So now I'm no longer interested in the index. So here what we can do, we can put a if statement. If idx equals to 0, in that case we can print brain tumor detected. Okay. Else what we can do, else we can print normal MRI scan. So that's what we will be predicting if it is normal. Now based on this value we'll get this result. Now again I will clear and try to refine the result. Let's see what happens if I do like this. Okay. Now you see here this is the 0 and the brain tumor detected. Okay, so likewise we can get the result if I do like this. Okay, so now let's make it more general. Now this time it is taking, by default it is taking some image and it is processing that, but can we make it user defined or user input, or can we add some user input in it? So definitely we may add some user input over here. And can we make a function for it, because this is executing like a script, but if you can make some function for it, then the function will be called only when I will be calling that function. So definitely we can make some functions. So let's make here some function called def predict function. So we'll make it as predict, and we'll pass some argument called image, and then this entire thing will be the part of our function, so will be shifted towards right. So control plus the square bracket, right square bracket, will shift everything towards right, and now this entire thing is the part of our function. Now we don't need this test image, so this will be an image which this function will receive as an argument. Okay, so this is the basic functions that we have studied previously, and now here at the end I'll take image as a variable, and this time we can take a user input. So input, and here we'll ask the user enter the name of image for testing. Okay, so now user will enter some image, and after that we'll make call to predict function, and here we will pass this image, right? So once I run this code, so let's clear this one, and once I run this, it should ask me the name of image that I want to test. And so see here, so it is asking the enter the name of image to test. So here I will put test.jpg. That's the image name. It will predict, and here it is showing brain tumor detected in this particular image. So this is how you can make it more general. You can take user input. You can ask user to enter something, and once it is given as an input to your system, it will predict the result, and that can be displayed over here. Now can we make in terms of some loop? So can you add some loop? So definitely, if you want, you can add some loop over here. So here it will be a while true, that will be infinite loop, and so these two things now will be shifted towards right as the part of while loop, and every time it will be asking in a loop. Okay, but we should break this loop as well once something. So at the end we can ask int, or let's say here we can take a variable equal to I equal to int input. Here we can ask enter 1 to continue and 0 to exit. So do you want to continue, that kind of thing? And here in the while loop we can put I, while I, and initially we can set I equals to 1. So initial value of I. Now again I'm making use of while loops that we have already studied. So I'm taking I as a 1. So initially while I, so I equal to 1, that means true. Or otherwise you can write here I double equal to 1 also. That is the same thing. And if you write I, that is also the same thing, 1 and same thing. So while I, that means I equal to 1. So image, here it will taking the input and then it will predict the result, so it will be printed, and at the end after prediction it will ask whether you want to continue or not. So if you put 1, so it will again ask for the image, and if you put 0, then it will exit. So that's what we are going to try, and let's check it out. So it is asking the name of image, so I'll put test.jpg, that's the image name. Hit enter, and now it has predicted brain tumor detected. Now it is asking enter 1 to continue and 0 to exit. So if I put 1, it is again asking me the name of image. So again I will put any other image, but this time I'm having only one image, so test image.jpg only, brain tumor detected. If I put 0, then it is exiting the loop and the program is now terminated. So this is how we can make this more general, more precise, and it can predict anything. So in the last session we have trained the model, so we need two different codes. First code to train our model, and second code to test that model. So these two codes will be required. Now in previous practicals we have seen only one code where we have just loaded the data, and that was tested for its operations. But this time we will be loading the data in first code, and in the second code we will be testing that particular code or that model. So we'll train our model, we'll save that model, and once the model is saved we can test it. Now for model training, in the last session we have developed this code, and you see this code is quite lengthy, and there are too many things in this code. So around 100 plus lines, 110 lines are required to develop this code, and number of steps we need to follow to train our model. This model we have to develop, and secondly we have to consider these epochs. So if you go for 25 epochs, then definitely it will take few hours to get it trained, depending upon your hardware configuration. So sometimes your computer may not have that high-end configuration. You may not have the graphics card or GPU. You may not have sufficient RAM. You may be having 2 GB, 4 GB RAM. You may be having the older CPUs, maybe Intel Core i3, i5 kind of. You may not be having the latest CPUs. So in that case, the training is quite lengthy process, and it will take larger time to train your model, and your CPU may not be able to handle that much training load, and will take large time to train your model. Sometimes your CPU may get heated as if you are not having any GPU. So to solve this problem, the Google has come up with a very excellent solution. They have a platform where you can train your model, and you can download that train model, and then you can consider this code, cnntest.py. So in that case, no need to worry about this cnn train.py wala code. But this is the process that the Google is also following. They are having this kind of codes at the back end. But as the Google is having the GPUs and TPUs. So their CPUs are very much powerful, and even GPUs they are having. So you don't worry about the hardware which is required to train the model. So the Google will take care of it and it will train your model. And once the model is trained, then you can use that model for your testing purpose over here, and you will be able to test that model. So for that purpose, the Google has developed a platform called Teachable Machine. And secondly, that platform is the programming less platform. You need not to write, you don't need to write not even a single line of code. Google will take care for each and everything. So that's the Teachable Machine for you. Now we'll discuss that platform also. We'll shortly check out that platform. And that platform is very easy to operate. Simply you will have to load your images to that platform and just hit the train button. Once you click the train button, it will start training your model, and once the model is trained, now it will be used to predict the result. Now let's go towards that platform first. Here I have opened a tab, and if you search on the Google for Teachable Machine, you just have to search on the Google for Teachable Machine. This will open, or this will show you some result, and this is Teachable Machine with google.com. That's the URL for this. Otherwise you can search for Teachable Machine on the Google, and you will get the very first link that will be this platform. So now this, as far as this platform is concerned, it's still it's in younger age, and this platform can recognize your images, sound, and poses. So basically right now it is only supporting these things. It can recognize your images, it can be used to recognize the sounds, and the pose recognition kind of thing can be done using this kind of platform. Okay, so that's all about it, and now we will get started with this platform. Now once we start the platform, now we have to select what we have to do, whether I want to do an image project, whether I want to recognize the audios, and whether I will be doing the pose recognition kind of thing. So I don't want to bother about these two things. So what I'll do, as this is my image project, and as it is still under development, so they will come up with some new ideas over here. Right now it is supported for only for these three things. So now as our project is image recognition only, so I'll be using this one. But in future they may come up with some different ideas. So we'll, in that case we can have some different recognition also. Maybe let's say SVM and the KNN architectures we have used for maybe for the car sales prediction. So such kind of things are yet not supported by this thing. But right now these three things are supported, so we can do this. So image recognition. So we can use this standard image model, this one, and basically as it support, let's say here 224 by 224 pixel for the color images, and the model size around 5 MB it will be creating, or this embedded image models, and this is based for the microcontrollers. Now the microcontrollers, such as if you have seen the Raspberry Pi or any other embedded microcontrollers where the computer will not be used for the machine learning or AI, in that case these models will be used. And you can check out here which kind of hardwares this is going to support. So mostly this is the Raspberry Pi, BeagleBone, such kind of hardwares can be supported. So I'll be using the standard image model as I'm doing this for the computer only. Now we are on this page. This is very interesting thing. Now here you need to mention number of classes. So now my first class is tumor or the brain tumor, and the second class is no tumor or the normal. Okay, now here what you can do, there are two options. Either you can start your webcam, and from your webcam you can start clicking the images or photographs, and that can be considered for this brain tumor category, or you can upload. So I'll choosing this option, uploading, and for the uploading I will have to click from my computer. So what I can do on the desktop itself, I'm having this internship folder. Inside that, this is the folder and my data training set and the brain tumor. So I will be selecting all the images and open. So it has opened around 155 number of images. Now for the second category, for the normal one, again I will be clicking the normal one. So this is the brain tumor, but right now I need this normal. So again I will select all and open. So now this has loaded 98 number of images, right? So I am having only two categories. First category is brain tumor wala thing, So I have loaded all the images. And again, if you want to add some images, you can add. If you want to delete some image, if this some sample is not good, you can definitely delete that sample from here. And again, for the same thing you can do for this thing as well. But you can start the camera also, and you can, for example, for face recognition, what you can do, you can start the camera, and you can recognize, you can click your photographs, and that will be used as your photograph, and you can take your friend's photograph in second category or in third category, and likewise number of categories can be made. Now once you have loaded the images, next step is training the model. Now you need not to worry about what kind of algorithms it is using. Basically it is using this CNN model and that 224 by 224 image size, but you need not to worry about the coding. It will be automatically generating the coding stuff. And here are some advanced features. And now the second step is training the model, and you get some advanced options such as number of epochs. So for how many epochs? Now there we have you train only for 5 epochs. Now here we are considering 50 number of epochs, but otherwise you can try for 6 number of 10 number of 20 100 number of things. Batch size 16, learning rate. So these are the some parameters that you can change, tweak, and based on these parameters your accuracy will vary. Now once you click on this train model, it will start training the convolutional neural network. So start training. So it has started training the convolutional neural network. It will first of all preparing the training data. So that means it will be converting whatever data you have uploaded. Out of that, 80% data will be used for the training and 20% will be used for the testing. So automatically doing that, and the epochs are now started. Now see how fast it is getting trained. Now for yesterday we trained for 5 epochs only, but it took around 1-2 minutes. But here it is training that very in very small period of time. Now we can check the accuracies of this model under the hood. By this you will get some graphs and accuracies of our model. So once we click here, here we are getting the accuracies and the loss. So see here, this is our accuracy. So our this blue color represents our training accuracy, and this orange color represents our testing accuracy. So now our accuracy has approached to 99.99%, and our testing accuracy, that means for the unknown data, it's around 74%, and now it is saturated after some time. And coming back to the loss, your training loss is now very less. It has approached to 0.002, but the testing loss is quite significant, is around 0.71. So that's quite high. So in that case, you can check our confusion metrics as well, what this confusion matrix is saying. So see here, for the brain tumor detection, the brain tumor normal. So if I give 24 number of images so of the tumor, out of that 24 images, 20 images are correctly identified and 4 are incorrectly identified. And when I give 9 plus 6, that means 15 images of normal category. Out of that, 9 images are accurately predicted and 6 images are incorrectly predicted. So this is quite significant. See here. So if you see 15 number of images, out of 15, 9 are correctly identified but 6 are incorrect. So 6 is huge number if you see here 9, if you compare 9 and 6, but here you can see the significant difference is there. So that means the training, that means the model is not trained properly. There are some issues with the accuracies. That means the 6 number of things will not be identified correctly. So in that case, we can actually retrain our model. So we have to retrain. Okay, I think there is some issue. Is there any issue? Okay, I think not. Okay, so in that case, we can consider retraining the model. So if you see the retraining, so in that case, what I will have to do, I will have to retrain the model. Once the model is retrained, again I can consider what I am getting here. So again I will start the training, and then again I may consider these graphs how I will get. So again it is preparing the data for training, and the training process is started. Now you can see here the graphs how they are varying. Again the accuracies are good, but the loss, testing loss is quite significant. So again you can retrain, and we will check the results after retraining. Again, now it's quite performing well. See here, it's now the decreasing impact, and yeah, now we can see this is quite interesting. Although it started increasing, but quite significantly. So it's around 0.25. Initially, it was 0.70. So now we can consider it's good. Otherwise, by increasing the number of epochs, decreasing the learning rate, and this batch size, we can get another results. Now we see the confusion matrix this time. Now this is quite good. So out of 24 images, 21 are classified correctly and only 3 are incorrectly classified. But for the normal one, it was 12 plus 3, that was 15 number of images. Out of 15, 12 are correctly identified and only 3 are incorrectly identified. So in this case, we can consider our model is having good performance, we can say. And once we achieve this thing, after that, we can export our model. Okay, so now we can close these graphs. You can save these graphs as well, and you can also check accuracies per class. So see here, for the brain tumor, that's the one category. So for this you are getting around 88% accuracy for this 24 number of test samples, but for the normal one we are getting 80% accuracy for 15 number of samples. So here we can see that for the brain tumor category the accuracy is quite high, and it has to be high because we are having 155 number of images in this category, and only 98 images are there in this category. So as the number of images are less, we are getting the lesser accuracy. So that's the performance of this network. And now we can click on export model, and here now it's time to download our model, and once the model will be downloaded, we will be using in our code. So we need a TensorFlow model, and now as we need a Python model or the Keras model, that's the libraries we are using. And see here, it is saying that it will be saved by .h5, Keras.h5 model. So that's what we need to download, and we will click download my model. So it will be downloading the model, and shortly it will download one zip file which will contain our model. So it is taking some time to convert the model. So it will download that model, and after downloading we will be getting the important model as a zip file. So it will take around 2 to 3 minutes to download, and now it has downloaded. Converted Keras 16, that's the folder. So I'll go to this folder, and now I will extract to this one. So now I got this one, and inside that I'm getting this Keras model.h5 file. So I will simply copy this model and I will put in this folder. Now this is my train model. So previously I was using this model. Now I will be using this model. And with this model now, we will check the CNN underscore test wala code. So again, we will go back to this one, and now instead, now not this CNN train, it will be CNN underscore test wala code. And instead of taking this train model, what I will be taking Keras model.h5. So here, instead of train model, which was the previous model, so I'll be taking this model now, Keras model.h5. And again, it is trained for the same data set on the same brain tumor data set. And now I will run the code. So after running, again, it will be loading this model, and it will ask me to enter the name of image. Now it is asking the image. So I'll be giving test.jpg, same image, enter. And now it has predicted. See, but in this case, you can see the probability value. So what you need to identify these probabilities value. So it is 9.99. So that means into 10 raised to minus 1. So that means 0.99. So 99% chances are there that this is brain tumor detected. But previously, our previous model was saying only 66% chances are there that this is the brain tumor wala image. But this model is saying 99% chances. That means it is more accurate. This model is more accurate. And 3.63 into 10 raised to minus 6, that means 0.00003. So that means hardly it is 0.003% chances are there that this is having the normal image or it is not the brain tumor. So that's the advantage, that this is more accurate, and as it is showing the brain tumor detected. And now I can put here 0 so that I can exit. So this is how the model can also be trained without writing any kind of code on the teachable machine. So now once you are introduced with this platform, teachable machine platform, now you can do anything. Now of course the sky is the limit for this. Now you can do the brain tumor detection, you can do lung cancer detection, you can do plant leaf disease detection, you can do anything. You can do face recognition, you can do emotion recognition. There are n number of possibilities now, and only the same code you will be using. Now I will ask you all to do different project. Everybody can choose his own idea. Otherwise you may pick any idea and just search for that data set. For that you may choose for the plant leaf disease detection, you may choose for the fruit quality detection, you may choose for brain tumor detection, you may choose for lung cancer detection, and simply search the data set for it on Kaggle or any other platform or on the Google. And once you get the data set, you just train your model using the code plus this teachable machine, and just download your Keras model, and using this you just complete your project. So everybody will do different projects using these techniques, and that will be a image classification project. You may do brain tumor detection, plant leaf disease detection, fruit quality detection, fruit disease detection, lung cancer detection, thyroid detection, anything you can try. And you just create a model and complete your project. Now one more thing, once I close this now, whatever I have done over here, that will be lost. Everything will be lost. Whatever images I have uploaded, so that will be lost, because this is not getting saved anywhere. So it is not linked with Google Drive or something. So it whatever you have uploaded over here, that will be lost once you click close to this tab. Now in order to avoid that, we can download these things locally. So for that purpose, this project can be saved to drive. So you can save this project to drive also, or you can download this project as file. So after clicking that, it will download this project as file. So it will be a project 7tm. And now I will close this one, and again I want to open this one. So again I will search for the teachable machine. So okay, this teachable machine. So I'll go on this teachable machine, and what I want to upload the my previous project or this file. So now in that case, I will be able to load my model from my file. So in that case, I need not to. Right now, you can see everything is lost. Nothing is there. No brain tumor. Nothing. So in that case, you need not to upload images again, as I have downloaded my project file. So from here, you can go and you can open project from a file, and then you can browse the file. It is now right now in the downloads. So this is project 7. Just open, and once you open, it will automatically load everything. Okay, it will automatically load everything, and then you can train and you can export your model, you can retrain your model. So these are the things. This is very much easy and interesting thing to do, and you can try number of projects. So I'll suggest you pick your own idea. You just maybe emotion recognition, face recognition, or anything, or maybe the gesture recognition, American Sign Language recognition, or the leukemia cancer detection. You may consider any project. Now you are in the position to implement any project you want, and that will be tested using these simple two codes that we have discussed in this today's session. Okay, so now this will be tested very correctly, and after some time we will be developing some GUI and the user interface for this also using the web development technique. So that will be in the futures step. So for now, that's the end for today's session. But if you are having any queries and doubts, you may put in the chat.